Hey everyone, it's Mr. Canfield back at you with another A+++ lesson. Today we'll be looking at straight line motion, also known as physics, but in math. So, consider an object moving along a straight line, either horizontally or vertical. Write down several of them. So, along a straight line horizontally, we could think about like an ant moving along a number line. We could think about a car driving down the street, a ball rolling across the floor, a bowling ball rolling across the floor. Vertically, we could think about a rocket shooting up into the air, etc., etc. Anyway, so a lot of times when we're looking at this, we're going to see position. You might think position would be represented with a P, because position starts with a P. For some reason, you're generally going to see position written as S or X. No, I don't know why it's S. X makes sense to me if we're thinking about it's on the X-axis, but yeah, no, I couldn't tell you why position and S are the same letter, and I don't want to pause the video and Google it right now, but maybe you will, and then you can tell me in the comments below. So anyway, sometimes we'll say y of t for it moving vertically, but again, S a lot of times stands for position. Just get used to it. It's okay. So it says, if x of t is equal to t squared minus 2t minus 3, show its position on the x-axis for t equals 0, 1, 2, 3, 4. I'm not doing this. This is literally saying plug in 0 here, you get a position of -3. Plug in 1, you get a position of, I said I'm not doing it, I'm not going to do it. Be like, plug it in, get the value. Wow, that's what its position is. So this is calculus though, and in calculus we talk about change. So think about what the change in position would be. So like, I'm here, then I'm over here. How do I change from one position to the other? I move, right? And so movement is the change of position. Another way we talk about movement though is the specific change from one position to another. The way you change is by some sort of velocity. So if you were going to say acceleration, acceleration is actually how we change our velocity. And if you're not sure what I'm talking about here, just picture with me for a moment what did this say? This said Braxton Hill. I wonder why it said that. Whoops. So picture with me for a moment. Just picture a speedometer. So, and the speedometer is here. Let's say that that's, 45 miles an hour. And it's just hovering there. It's not changing, it's just hovering there. That means that your current speed is 45 miles an hour, but you're not accelerating or decelerating at all. The only way for us to change our velocity, our speed, is to move this needle from here to here or somewhere else. So if we move that needle, we had to press the acceleration pedal. The only way to change our velocity is to use acceleration. So just to make this super clear, position, we take its derivative and we get velocity. Velocity, we take its derivative and we get acceleration. And then there are other fun ones. The change of acceleration, my nickname in high school was jerk. And then the change in jerk is called snap. And so like you could take the derivative of acceleration and you get something called jerk. We don't do that in this class. It's just funny. You take the derivative of jerk, you get snap. We're going to talk more about what these mean later, but for now, it's useful to know. So something else, we'll get there. So he talks about speed and other things. I want to do a problem. I think looking at a problem and talking about it is going to be really good for us. So a particle moves along the x-axis with position function s of t is equal to t squared minus 4t plus 2. So velocity is really this simple. Velocity is going to be the derivative of this, which is going to be 2t minus 4. And so at any given time, if we plug that in, that would tell us the velocity of the particle. Not where it is, but the velocity of it. And then acceleration, we just take the derivative of velocity, and we'll get 2. So I should mention that since it says s of t, t is going to be the variable with which we respect when we take. I'm not going to use big sentences because I'm going to mess them up like that. T is the variable that we are taking the derivative with respect to. Word salad. Okay. I've been on break too. I'm filming this right after winter break. So it says complete the chart for the first 5 seconds and show where the particle is on the number line. Okay, so let's see. If I plug in 0 to position, I get 2. And at that time, if I plug in 0 to velocity, I get -4. So what does a velocity of -4 mean? It means that our particle is moving to the left 4 units per second, I guess, because it says time is seconds. So left 4 units per second. So that's called velocity. If you take the absolute value of that, you get 4. This is called speed. In general, speed is going to be the absolute value of velocity. In BC, we get into some more details about how speed works in different situations. But in general, especially in this class, speed is going to be the absolute value of velocity. And its acceleration is going to be, well, my second derivative, I got 2, so 2. So at time t equals 2, or sorry, t equals 0, it's right here, but it's moving to the left with a speed of 4, and its acceleration is 2. So let's think about this. Is it speeding up or is it slowing down? Well, the acceleration is saying the velocity is going up by 2 per second. Well, the velocity is currently negative. So in reality, if the velocity and the acceleration are opposites of each other, they actually fight each other. So it's currently going -4 feet or -4 things per second, but that rate is increasing by a factor of 2. So let's see what happens when we plug in 1. I think we'll start to see this velocity, something interesting is going to happen to this. So at 1 second, when I plug it in, I get 1 minus 4, I get -3 plus 2, I get -1. Now, according to our velocity at t equals 0, it says I'm going to the left at -4. I think I just wrote the wrong number here because I was thinking, let me restate what I plugged in 1. 1 minus 4 is -3 plus 2, -1. -1, okay. But it was supposed to go to the left 4 and only went to the left 3. It's because velocity is actually changing over time. That speedometer isn't just perfectly sitting on something. That speedometer is wiggling around. And let's see what the speedometer reads at -1, or when t is 1. 2 minus 4, I get -2. Oh, it's only going to the left 2 units per second now. If we took the absolute value of that, we get the speed of 2. And let's see, the acceleration is, oh, wait a minute. A of t is equal to 2 in this situation. It's going to be 2 every single time. So I actually can kind of do this velocity without even thinking about it. Right? If I added 2 to get there, I'm going to add 2 again. It's going to be 0. And if you don't believe me, just take 2 and plug it in for v of t. We'll get 0. Then we should get 2, 4, 6. Let me just double check to make sure. So 5, if I plug that in, I get 2 times 5 is 10. Minus 4, I get 6. Okay, so my thinking was true. Acceleration is changing our velocity. And sure, we can take the absolute values here. We get 0, 2, 4, 6. So notice at 4 seconds and 0 seconds, the speed is the same. But at 0 seconds, it was going to the left that fast. And at 4 seconds, it was going to the right that fast. So if we're looking here, if we look at our different velocities, -4, -2, 0, 2, 4, 6, these numbers are increasing the whole way. But think about the speed. It's going -4 to the left. It's going really fast. Then it's going half as fast. Then it's going no fast. Then it's starting to go fast, and it's going faster, and it's going faster. And so the thing that we're going to notice is that anytime the sign of velocity and acceleration match, the speed is increasing. It's going to be getting faster and faster and faster anytime velocity and acceleration match. But anytime they're opposed to each other, -4 and 2 here, -2 and 2, they fight each other, and that's going to make your velocity get closer and closer and closer to 0. So it might be a little bit confusing now, but if you go back to the previous page and look at his tables and read his explanations, I think he'll help it make sense. I think he does a really good job explaining this. Again, I just like to give my own spin on things and give you a chance to think differently than he has it written, and then you can go back and look at the way that he wrote it. So let me just finish filling this out. So plug in 2 there. It's 4 minus 8, -4 plus 2, -2. Then at 3, let's see, at 3, it's going to be 9 minus 12 is -3 plus 2 is -1. At 4, it's going to be 16 minus 16, I got 2. And 5, 25 minus 20, I got 7. Wowzers. So if you look here, starts out at 2, goes to the left. So it starts at 2, goes to the left down to -1, down to -2, but then back up to -1, up to 2, and then all the way up to 7. Interesting. So that's not something that we're going to be able to graph in this class. If you want, I guess we could graph position over time, but it's going to be hard for us to talk about velocity and acceleration all on the same graph easily. So in general, if your velocity is positive and your acceleration is positive, if velocity and acceleration are both positive, it's getting faster. The speed is getting faster. If one's positive and one's negative, the speed is getting slower. So if we move on, it says, determine the time intervals where the particles traveling on a straight line are slowing down and speeding up. So let's look at this first one. Let's see. I want to use, whatever. So the way how we're going to figure out if it's slowing down or speeding up, well, we're going to need to figure out velocity, and we're going to need to figure out acceleration. So if I want to figure out velocity, that's the derivative. So my velocity is 2t minus 6, and then my acceleration, when I take the derivative of that, is just, the derivative of that is just 2. Here, hold on one second. All right, that should be a little bit better. So let's look at this. The easiest way to do this is with what's called a sign chart. We did these earlier in the year, but we're going to set this up a little bit differently. So we're going to deal with our time values on the top row, and then on our other rows, we're going to look at, well, if I'm going to look at velocity, then I'll look at my velocity here, 2t minus 6. That's my velocity. Got my my Thor pencil. I know things about superheroes. That's his hammer. Yeah, okay. So the thing is, I don't know what t-values I'm actually going to care about. In general, the t-values that we care about are the places that it's going to be changing sign from positive to negative. And if you remember earlier, there was a point when our velocity changed from negative to positive. That happened when velocity was 0. And it turns out when velocity is 0, or the first derivative is 0, that's going to be a really big deal to us. And we're going to spend a lot of time trying to find those numbers in the very near future. But for now, let's see. We want to figure out, when does this equal 0? You might remember that's called a horizontal tangent. So I'm going to add 6 to both sides, divide by 2. I get 2t is equal to 6, divide by 2. I get t is equal to 3. So when t is 3, our velocity is 0. What happens if t is less than 3? Any number less than 3. If I plug it in, let me try that. And I'm not actually writing a number here because I don't need to. Any number I pick is going to give us the same result. It's either going to be positive or it's going to be negative. If you're stuck, physically write a number and like, oh, I'll just try 1. Okay, plug in 1. I get 2 minus 6. I get negative 4. Oh, I got a negative number. Okay. What about a number greater than 3? So any number you want. I can pick 400 if I want. I don't know why. Plug it in there. I get a 800 minus 6. Oh, I got a positive number. So the velocity, when t is less than 3, the velocity is negative. When when t is greater than 3, the velocity is positive. So then, let's pay attention to what acceleration is. Wait, acceleration is always 2 in this problem. That means it's positive here, it's positive here, and it's positive here. So if we think about that, that means it's going left but accelerating to the right. So that means that they're fighting each other. Remember, anytime velocity and acceleration have opposite signs, it's slowing down. What is it when your velocity is 0? Like if a cop clicked his radar gun on your car and it said 0, it means you're not moving. So for this brief moment, it stopped. And then what about here? Velocity is positive, acceleration is positive. They're going together. That's speeding up. Now let's look at a more interesting example. T cubed minus 3t squared, that's our s of t. So then our v of t will just be its derivative, which is 3t squared minus 6t. And then a of t, the reason I say it's more interesting is a of t is not just 2 again. So come on, straighten out the, there you go. So a of t will be what, 6t minus 6? So this time, if we're trying to find the velocities of 0, we could say, well, let's set this equal to 0. And then we're trying to solve this. This is not as straightforward to solve. It's factorable, though. So I could factor out a 3t. If I do that, take a 3t out there, there's a t left over. So I'll say t minus and then 6t. We divide by 3t. We'll get a 2. Let me just double check. 3t times t, that gives us 3t squared. 3t times minus 2, that gives us minus 6t. Okay, so now it's factored. I can just set them both equal to 0 and solve. So when does 3t equals 0? Divide by 3, we get t equals 0. When does t minus 2 equals 0? Add the 2 to both sides, we get t equals 2. So that means that there's 2 points in time where this particle is going to be paused, where it's going to have a velocity of 0. The 2 times are when t is 0 and when t is 2. So if we set up our sign chart and say, here's t, we're going to have a 0, we're going to have a 2, and you want to make sure you put them in chronological order, like they were on the number line. So you might be wondering, wait, why are we doing negative time? It's important for us to consider what would happen before the time that we start doing this, or at least I'm going to say that it is. Maybe it isn't in this situation. I'm going to delete that illegal to post on the internet. Thanks, Stu. Whoops. All right. So fair use. Okay, let's see. So if instead of just writing my velocity in one thing, we could write our velocity as 2 separate things. We could say 3t and then t minus 2 and then say v of t to kind of give ourselves an easier way to calculate the sign of velocity. So like if I were to plug in -1 here, I get a negative and then a negative, and I know that they're being multiplied together. This is the factored form. These are both my factors. Negative times a negative gives me a positive. So I know when t is -1, velocity is positive. So I plugged in a -1 there and a -1 here, we'd get a -3 and then a -303 again, to be +9. So that's a positive there. And then we know when t is 0, my velocity is supposed to be 0. Let's see if that works out. Plug in 0 here. Well, 3 times 0 is 0. And then t minus 2, it's a negative, but who cares? Because a 0 times a negative is 0. And then, let's see, pick something between 0 and 2. I can pick anything I want. I could pick 0.1 if I wanted to. I'm just going to pick regular 1, though. It's a little bit easier for my brain. Plug in the 1 for the 3t, and I'll get positive. Plug in the 1 for the t minus 2, and I'll get negative. So positive times a negative is a negative. And then at 2, we were expecting it to be 0 again, because that's what we solved for a minute ago. So at 2, sorry about that. At 2, let's see, I plug in the 3t, I get positive. Then at t minus 2, I get a 0. Aha, positive times a 0 is a 0. And then same idea, pick a number bigger than 2. I'm going to pick 1,000. I wrote 10,000, so I'm going to pick 10,000. And I plug it in here, I get a positive. Plug it in here, I get a positive. That means velocity is a positive. So if you think about this, our velocity, we're moving to the right, we're stopped, we're moving to the left, we're stopped, we're moving to the right. On its own, we don't know if it's speeding up or slowing down in these intervals. And so there are ways for us to figure that out. We want to find places where the acceleration is going to either match or not match. And we'll talk more about that as we move on. In this particular situation, just for those of you who like to think a little bit deeper about things, this was the main part that I wanted us to think about, that it's moving to the right, stopped, moving to the left, stopped, moving to the right. It's important for us to realize that the acceleration winds up being 0 when t is 1. And so if we had another little spot here for acceleration, 0 here. And so it winds up being positive over, let's see, it winds up being negative over on this side, and then positive over on this side. And so we wind up having a kind of similar situation where the particle's slowing down, stopped, and then it's going to do something weird in the middle here. There's going to be some more things we'd have to do. I'm out of space. Don't worry too much about it. I know I'm kind of fumbling over my words. We'll see more problems where we can look at the details that happen here. I should have made my sign chart a little bit more detailed, but don't worry. At least if you're in my class, don't worry. All right, let's see what Stu says next. On the AP exam, you are frequently asked to find time intervals when the particle is speeding up and slowing down, and also has to justify your answers. Sign charts are not justifications. So here's what happens during the test. I've been told this by somebody who actually grades AP tests. She was one of the people who trained me when I was getting ready to teach AP for the first time. She says, when we read tests, we physically cover up sign charts. We are not allowed to use them to grade your papers. Which I'm kind of like, well, that's kind of dumb. But part of it is there aren't a lot of words going along with them, and they really could mean anything. So they don't want that to color the way that they're looking at your paper, either for the better or for the worse. We're going to need well-explained evidence to show our work. So we'll get into that. So the justification that he's got, the particle is speeding up and he gives a time interval here. So instead of going 0 is less than t is less than 1, you could also do 0, 1. You could say for t on 0 to 1 and to infinity. Oh wait, 0 to 1 and then 2 to infinity. I should put a U in the middle, a union sign. because v of t and a of t have the same signs on those intervals. You could also say the particle's velocity and acceleration have the same signs on those intervals. The particle is slowing down from 1 to 2. You could say 1 to 2. You could say on 1, 2, because they have opposite signs on that interval. So it's more or less a definition. If you know that speed is increasing when velocity and acceleration have the same sign, so what, 20 times now this video, that's it. Let's see, we can also make a sketch of the position of the particle. We can define a critical time as any time when the particle is stopped. We're going to talk about critical points a lot in this class. With that word critical, that means the derivative, or the velocity in this case, is 0. And since we generally are going to be considering t to be positive, we'll include t equals 0 as a critical time. That's going to be a time we also want to check. Maybe it's starting out from rest. All right, but let's do one more really good example, and then I think that's going to wrap up today's video. A particle is moving along a horizontal line with position function blah. Do an analysis of the particle's velocity, acceleration, motion, and position. Okay, so let's talk about this. We're going to assume, since Stu said it, instead of going on to negative times and stuff like that, we'll just assume time starts at 0 this time. So let's find v of t. That's just the derivative. So let's see, t cubed, that's going to be 3t squared. Then minus 9t squared, so that's going to be minus 18t. And then plus 24t is going to be plus 24. And then the 4 turns into a 0, so it's not there. And then the acceleration is going to be that derivative. So 3t squared will turn into 6t minus 18t will turn to minus 18, and that turns into a 0, so it's gone. All right. So I'm going to want to find the places that these are both 0. I'm going to do a better job than on the last problem. So let's see. When does this equal 0? Well, I see they all have a 3 in common. I'm going to factor a 3 out. So let's see, 18 divided by 3 is 6, 24 divided by 3 is 8. Okay, that should be good. And then I'll factor that. Let's see. And remember, when we're factoring this, we're looking for two quantities. They have to multiply to equal that last term, and they have to add up to equal that middle term. So I see the 8, and I immediately go to 4, 2, because 4 times 2 is 8. But 4 plus 2 is not 6. It's a positive 6, and I'm supposed to get negative 6. So I can do negative 4 and negative 2. That's still a positive 8, and then negative 4 and negative 2 is a negative 6 when you add them together. So that tells me that this is t minus 4 times t minus 2. So then we actually have to go through and solve it. So we get, when does 3 equal 0? No, it doesn't. When does t minus 4 equal 0? Add the 4 to both sides, we get t equals 4. What about t minus 2 equaling 0? Well, that happens, we add 2 to both sides, we get t equals 2. So velocity is going to have, it's the times that velocity is 0, I mean t equals 4 and 2. We called 4 and 2, we're going to call those critical numbers, or critical points, or critical times. So, and also go to our acceleration. When does this equal 0? Let's see. So, I'll add the 18 to both sides. Divide by 3, I get t, or 6, sorry. T is 3. Okay. So, if we do an analysis here, the sign chart is going to help us think about this. So I've got important numbers of 2, 3, and 4. Oh, those are all kind of in a row. So 2, 3, 4. And then I'm going to do what I did before. Now that's a positive number out front, so it's not going to affect the sign ever, right? Because a positive times a positive doesn't change it. A positive times a negative doesn't change the negative. So this was never going to affect anything, but t minus 4 and t minus 2 are going to affect things. And then 6t minus 18. So, oh, I should put a little spot in there for velocity. Let me move 6t minus 18 down. So figure out what velocity is, and then figure out what acceleration is. So we can start out, and if you believe me, I don't need to calculate the zeros every single time. I know the zeros are 2 and 4 for velocity, so I know at 2 and 4 they're zeros. I know acceleration is 0 here. So, and so now if I just kind of go through, well, let's pick, like, I'll pick a 0 here. 0 is less than 2. So between 2 and 3, like 2.5, that can work. So between 3 and 4, that's like 3.5, that can work. And then 1,000 for after 4. So I just like picking up big numbers. I don't know, it's fun. Okay, so let's see, let's get that all in frame. Okay, so if I plug in 0 here, I get a negative, and then another negative, so that's a positive. Here, I should just get a 0. And then here, 2.5, I get a negative and then a positive. So that's going to be a negative. And then at 3, I get a negative still and another positive, so it's still a negative. 3.5, still get a negative and a positive, so it's still a negative. And at 4, I get a, oh, it's a 0, right? Then at 1,000, they're both positive, so the whole thing's positive. Okay, so now I analyzed my velocity. I'm able to say when t is less than 2, my velocity is positive, so I know it's moving to the right. At 2, it stops, and then between 2 and 4, it's moving to the left, and then after 4, it's going back to the right, because at 4, it stopped. So now we get to analyze if it's going faster or slower and how that's working. So at 0, let's see, a of t, which was 6t minus 18, right? 6t minus 18, so that was negative. Then at 2, still negative. At 2.5, still negative. At 3, it's 0. So at 3.5, because 3.5 times 6 is going to be more than 18. It's going to be positive. 4, more than, yeah, positive, positive. Okay. So if we look at this, anywhere that our signs are going against each other, that is the speed decreasing. So I can say speed decreases on 0 up all the way up until 2. When we hit 2 and it stops, then things change. And I'm not putting brackets, I'm putting parentheses to say at 2 that's not happening. And then let's see. So here at 3.5 it is. So what two signposts is that between the 3 and the 4? So, and speed increases on, let's see, where do my signs match? In between 2 and 3, and then let's see after 4. So I can say 2 to 3, and then union after 4, so 4 to infinity. So we can talk about the speed like that. Let's talk about, let's see, velocity. Velocity, so we could say v of t is greater than 0 for t, for the t's that are on, let's see, when is velocity greater than 0? 0 to 2, because at 2 it's 0. And then in between 2 and 4, our velocity is negative, but then after 4 it's positive. You can say from 4 to infinity. So we'd say velocity is less than 0, which, if it's greater than 0, we could say moving right. And then we could say here moving left for t on, what, 2 to 4? And that takes care of, I think that takes care of everything we need to talk about. We could talk about its position when it's left and right of the thing. And we could do that by solving the S of t. But this takes care of one of the big ideas that we need to get across today. How velocity and acceleration play with each other, how we can figure out when one is positive and one is negative. So I think an additional thing that I should mention here and just think about. So we said velocity is equal to 0 at 2 and at 4. Are there any other times that this particle is at rest? Because we know the particle is at rest when t is 2. We know the particle is at rest when t is 4. When else is it at rest? And this is theoretical, because it's not a real particle. But the answer to that is never. The only 2 times this particle is stopped is when its velocity is 0. And it's a quadratic equation. There's only 2 answers to that. It's not possible to have more answers to that. And so because of that, we know there's only 2 times it's stopped ever. So hopefully that line of reasoning was helpful. So it looks like we've still got a bunch more to go through. But I hope this was kind of a helpful start to things. Yeah, even though these word problems are lengthy, I think this tackles some of the biggest ideas. So if you are looking to get some practice out of this, that looks like the first 4 homework problems are going to be really good practice for you. So yeah, hope that was helpful. Have a great day. Bye.